Hi, I'm Everett. Welcome back to the shop. This video we're going to get back on the shaper, and what we're going to do is we're going to wire it up. The wiring that it had from the factory may have been good for the 1940s, but I don't really like how the terminals were sticking out on the inside. And the fact that it didn't have any of the modern safety features like the magnetic switch, where with a magnetic switch, what happens is, for those who haven't taken one apart or been inside the electrical box of a piece of equipment, what it does is it's a safety device where the main contactor is held in place with an electromagnet, and if the power goes out to the machine, that electromagnetic or magnetic relay lets go, the contactor, it lets go, and the machine will not start again until it's been manually reset. It's a safety feature, and I know this machine never came with one from the factory, and hanging an electrical box off the side won't really look like 1940s, but I'd rather be safe. These machines, if taken care of, will outlast any of us, and I figure for a little man, if he inherits it or we wind up selling it to somebody else at some point, at least then I know that it'll be functionally safe, safe to modern standards anyway, as far as starting it up. Finally, I have all my components here. The last few finally showed up a week or so ago, and turns out that I had to fiddle with a couple other little bits. Got my hole saw for putting the switches and the lights in, and we just need to sit down and put it together. Now, I do have to do a little bit of machining this video. My buddy Eldon gave me a heat sink. This will be for the solid state relay, or SSR. We're going to have to take these two fins, or well, channel pieces off there. We're going to use this part of it. So what I'm going to do to hold this down is actually pretty simple. This is a 3/8 inch thick piece of bar with holes in the ends, nice and plated and looking really nice. Leftover drive shaft steady bearing shim from a lift kit. You don't always use every shim in every installation, so one of the guys I was working with, the dealership I was at before, saved me a bunch because, well, a lot of them just hit the scrap metal bin and got recycled. I saw that and went, ooh, metal. Shiny. Kind of like a cross between a pack rat and a raven or a crow. Some form of corvid. Shiny. And yeah, I'm just going to use the slitting saw and buzz down the edge. But yes, I know there's a bit of run out in that, in the blade where it's spinning. One of these days what I'm going to do is I'll probably revisit this arbor, and I'm actually thinking about turning it on the mill itself. And I can tell right now this is liable to get loud. Not bad. So yeah, a little bit of a lip there, but not much. I'd rather have a little bit extra to take off of the file than not enough. So that'll work just fine. I'm going to flip it around to the other side, and I'll meet you back at the bench. So with the fins cut off, or those two ribs in the back, a little bit of time with the manual milling machine and a little bit of Scotch-Brite to clean up the scuffs, we have ourselves one heat sink. Now, what we're going to do is, well, first off, we're going to set the screws aside so we don't lose them. But what we're going to need to do is we need to figure out where everything's going to mount. Now, my original intention, and this is what I'm kind of hoping to do, is we'll mount the heat sink there on the one side, these tabs going, vertically on the machine, so it's actually supposed to sit like this. I want vertical because that way it allows the warm air from the SSR to move upward and then draw in cooler air from below. The thing is, we've also got a couple lines, well, 3 lines that have to come in. So I'm thinking we'll mount those like so. Well, I guess we're going to have to deal with the nut on the inside on that one. So that's my thought with that. One for power in, like from the wall. One for power out to the motor and power and return from the motor, and one for our control circuit. So I guess first thing we need to do is figure out where to cut the hole for this guy, because the SSR will be mounted straight to the heatsink like this, but poked into the case. So we need to cut a rectangle in the side of the case large enough to accept the SSR, but still pretty, close to center the heatsink, on the side, with about 3/16 to a quarter of an inch, or well, a few millimeters anyway, space on the front to allow the lid to close. So that's my next step, is figure out how I'm gonna, or where the SSR is gonna mount. There. That will be good enough. All right, well, so at this point here, as I say, that's going to be mounted there, but, well, the other way around. The nice thing about this one is the precision is it just has to fit. So it looks like I may even be able to come inside of my outside lines a little bit, make it just a hair longer. So here goes. 3/16 end mill. Using more of those lift kit shims. More of those lift kit shims for the for clamping this part down. This could prove interesting. Wonder if that needs... give me a minute here, I'm going to rethink the clamping. Alright, let's give this a shot again. Now, today's second sketchy setup is brought to you by the fact that being a plastic box, I also don't want to crush it as I'm working on it, so let's see where we're at again. I know I could have used a jigsaw, but I think this is going to give it a nicer finish. Make it look a little more pro. So that will tuck up into there just nicely. Perfect. So with our SSR mounted on the heatsink, kind of go like that. Now before I go too much further here, so I know how much space I have to work with over here, let's figure out where the heatsink has to mount on the SSR. Seems as good a time as any to use a Randy Richards scribe because it's long and pointy. There we are. We'll be using number 832 screws to hold the SSR to the heatsink, so we'll drill a couple 3/16 holes there. We're going to use the small drill press for this one. And 3/16 drill bit mounted in there. Please pay no attention to the disaster in the shop. Now what I'm also going to do is 3/4 of an inch in from the end on the outermost fins. I'm also going to drill holes out here because the heads of the screws just clear the fins. These are going to be the mounting holes to mount it to the side of the box. There we go. Some of those holes were in there to start with. They'll just, yeah, I can live with them. Not a big deal. Now that we have our holes drilled, and yeah, they'll match up well enough. In order to make sure that I have good heat conductivity, we're going to need some thermal paste to put between the back side of the SSR and its heatsink. Now, I don't actually have a tube of the thermal paste. I know it's not stupid expensive. However, one of the things about being a pack rat is you sometimes come across, you have junk already in place that will work. And so a while back I was showing how I take these guys apart to save the brass. I was saving the brass for my dad. This is a coolant temperature sensor. Inside here is a negative temperature coefficient thermistor, and it's actually packed in that white goo, the thermal paste. So we'll peel this guy open and reuse the paste in it, and then I'll give the brass to my dad. So this is actually what we were doing to take these apart. Both the coolant temperature senders and the oil pressure senders. That little crimp there is just rolled over, holding this plastic bit in. If we take that crimp off, that plastic part comes out. There we go. Now it doesn't take much, and there's more paste down in the tip of the case there. So yeah, this will work just fine. So now it's just a matter of taking our SSR, our newly disassembled coolant temperature sender, scrape the grease that we can off of there. My dad's a genius. He'll never admit to it, but he is. I mean, he was the one who came up with the idea. I told him I needed some of this thermal paste, and he said, why don't you just take it out of, have any more of those coolant temperature senders? I never thought of that until he brought it up. Now, the primary area of concern is right back here where the control portion is. As you can see, that when this gets smushed onto the heatsink, it'll squeeze out all more so. As you can see, there's quite a bit in there for such a small part, such a small car part. So yeah, thanks for the idea, Dad. Saved me having to buy a tube of the goo. So as I say, the nuts are actually caught by the fins, so it's nice I can just tighten down the screws. Make it nice and snug. We have thermal paste oozage. That is a good sign. There. Not going anywhere. All right, now comes the next step of getting the wires in. Now I'm going to have to pretty much snug that right up with the hex right up against the heatsink, just because of how, where the heatsink wound up going. I have space to my front cover. Probably could have moved it over by a few millimeters, but whatever. C'est la vie. I should have enough space inside for the big nut, I'm hoping. If I don't have space inside to take the full nut, I'll take a couple of these little lugs off the outside off. We'll make it work. I realize I'm trying to fit a lot into one panel here. And this guy. There. That will have to do it. Now the hole saw had a pretty bad center on it, so we'll use a center drill. Plastic can sometimes be a pain to drill. So there we have the 3 holes. Again, they're all just a little bit undersized, but I'll just use a round file, clean them up, get them to the right size. You sometimes just have to fit and finish these things. Okay, confession time. I made a slight error. Not a huge deal. Remember I was saying how I could have taken, you know, a few more millimeters or a few, you know, probably 1/8 of an inch or so going that way. That would have been actually a good idea. 1/8 to 3/16 going that way, or a few millimeters rather, because as it is, the steel nuts back there used to hold these bulkhead fittings or whatever they're called, the threaded strain reliefs. Yeah, I had to actually take the grinder and just take a little bit off the back edge of them just to make sure that they fit up against the back wall. As well, this one here, I had to take one of the lugs and adjust it a little bit with the grinder in order to clear the nut for the, you know, SSR heatsink. One way or another, it'll still be fine. It'll still work for our purposes. I should have moved it to the front by a few, you know, few millimeters, or probably 1/8 to 3/16 of an inch. Anyway, we know where the SSR mounts, and it's only just a little bit past where the strain reliefs sit. So now it comes down to figuring out where I can mount the switches so I can, you know, pop them through and they don't interfere with each other. Because, I mean, for example, that switch and that switch, when they're mounted, should have a little bit of space between them. So probably something about that. I'll sort of fiddle and fart with this till I figure out where I want to put them, mark it, and then I'll bring you back in. Now before I try to break my hole saw arbor here, I liked what happened with that last time when I was cutting holes using the center drill to locate it first. Now this isn't where this one's going to go, but I would say that's acceptable for where it needs to go. Four holes, roughly set out in a nice little pattern. There. It worked well enough for what I needed. Alright, a little bit of deburring. We'll mock up our switches. Well, it's been a couple days and managed to get back at this again now. The best way I can see to arrange this on the inside would be, let's set the contactor in the front with just enough space off the front wall there to give us space to connect the connectors. I'll run screws through the bottom here with nuts on the back side in order to hold this to the case, and I will ground the plate at the base here that is mounting that contactor to the box. That way, you know, the whole thing, what if you have a loose wire? If it touches there, it'll hit ground, pop the breaker, we're good. As for our little 5-volt switching power supply, what I did was off camera, I took this piece of plastic here. I got it out of a block, just basically sized up the board against the block, used a bandsaw, cut the little block out, buzzed it through the mill to clean it up on the faces that needed it, cut some channels and grooves in it, and then what that now gives me is a little block with pads. And those pads have holes in them lined up with the mounting holes of the little circuit board. And I have 2 holes in the back that are 2 1/4 inches apart. What that allows me to do is run 2 screws in from the bottom and or mount this to this little board here with some screws, then mount the block to the bottom. We have no electrical connection through there whatsoever, because otherwise, in order to be safe, I'd have to ground all 4 of those screws, and just not worth it, all 4 of the mounting screws. So this is about the safest way I can think of doing it. Well, that's pretty much most of it, except for setting up the ground. I won't be able to hook the ground up until it's actually mounted to the machine. But for that ground, we are going to need a 1/4-inch hole through the back. I'm just trying to find a spot where it's going to be reasonably convenient. Well, as convenient as possible. There we are. So that, shake all the plastic out. Thankfully it's non-conductive. So that hole in the bottom there, you can just see the white of the blotter through it. What I'm going to do is I'm going to figure out where it's going to mount it to, drill the holes to mount it, mark that spot there, drill a hole through the case itself, and then run a stud through with a nut. And that way I can take and put all these different ground connections straight to there. Everything in here is bonded to the machine. Any exposed piece of metal, like the heat sink here for the SSR, the nuts here that are holding the contactor in place, all that stuff is going to be grounded, so that way it'll be safe. Well, it just came down to the fact that in order to get the wiring attached to the motor, the pigtail that was on here before wasn't long enough to reach the control box. That's why I added that chunk that I was working with on the bench. So we now have plenty of slack. It comes around through to the backside here through a 1/2-inch bushing that's in the casting. There's another hole that'll be plenty big enough for the control circuit, which is only 5 volts and won't be a real hazard. That will go through that hole. Now we have it mounted. I just used some screws and nuts to mount it to the case. We have our little stud set up in the back there. Once I got the ground lines in there, I've gone through and made sure I have no nasty rub points, like say a ground wire sitting right against a hot terminal that's going to rub through eventually. So theoretically, we should be able to plug this thing in and we shouldn't have any nasty smoke. Theoretically. I have no belt on it right now, just for safety's sake, for testing. So we'll close that. This will be like turning the switch on the front. Okay, why not? That's on, that's on. Okay. Interesting. Huh. Okay, I'm going to have to look through this. I'm going to have to inspect this again. So really all it comes down to for the control system now is to wire up the switch. And so for that, what I've done is I cleaned up the terminals on the front contactor here. Anything control related inside the box is blue. We'll consider this, part of the control system. Truthfully, I didn't buy this. I didn't buy the color or whatever. I pulled it out of a dumpster at the neighboring apartment building. It was missing the one end. I suspect somebody drove away with their block heater cord connected this winter, because that's when I found it. Like I say, I just think this switch is really cool. So I realized it was just sitting there unconnected, or disconnected rather, who knows how many years. Again, the switch that was on the back looked old. And I've seen some units where, people have replaced these switches in the front, or maybe they didn't get them when they got the machine or whatever. But the switch in the front was a modern looking push button style, with the whole safety mechanism in it and whatever. But that, let's see, once it weasels in. Yeah, there we are. That I think looks cool, or will look cool. Come on. There. Now, man, just even looking at how close these terminals would have been to the actual case running, you know, and these things are 443 phase machines. So 400 volts. Seeing how close these terminals are to the actual casting. Now I was debating whether or not to paint that name or that faceplate here, but I decided against it. I think the old school, you know, just the basic plain aluminum look looks okay on it. There. And then I don't have the two British Association thread that goes, or set screw that goes in here, that then holds it to the switch. Alrighty, so we have the shaper plugged in. I got the clutch disengaged right now. Theoretically, we should be able to just turn on the main control, or the enable, flip the switch, throw the lever, we should have movement. On. On. Sweet. Oh, that makes me feel better. All right. So that's, I don't know, I just think it's really cool that we got it now running. We're using the old school switch on the front in order to actually, you know, turn the machine on. I realize in the back we have our all of our safety enable type stuff. And if we lose power, or if I unplug it, plug it back in, it will not start again until I hit the electromagnetic enable, the green switch. So we have our green switch for start, basically enable, the red for, you know, when I want to turn it off and have no current flowing through anything for the day, or for the evening or whatever, and then the emergency stop. I'd thought originally about putting it on the back to try to, you know, keep the old school factor of this thing, cool factor going. In reality, this is the operator's position. It's probably better to have the emergency Murphy switch right there that I can smack right quickly, rather than having to reach around the back as I might be snagged in something. So that's why I decided to put it on the side instead of the back. So yeah. I like it. I'll shut it off, shut that off. And I'll call that an evening. I'm happy to see that. So next process is really, we're getting close to the end of the actual repair of this thing, and hopefully closer to using it. I got a package in the mail from Tony Ray with some hardware, like the knob up here and some you know, some other hardware. A couple small pieces of hardware I'll have to make, and I also have to repair the linkage that goes between the bull gear retainer here and the advance for the table, side to side. So anyway, yeah, I got to fix that yet and make a couple pieces for that. But other than that, once we get that done, I guess we got to do the vise yet. But once we get that done, then we're once the vise is dealt with, then we can start using it. So. Cool, I'm happy with that. So I hope you found it interesting. I hope you find what's coming up interesting as well. It'll be, again, more work for, you know, getting the shaper fixed and then actually using it. I've also got a couple projects that came in recently that I just videoed, and I haven't released any footage or whatever yet. I got to edit that yet. I found them interesting. You might as well. So thanks for watching. Thanks for subscribing. If you haven't subscribed, that's cool. Thanks for coming by. It's good to have you here. Thanks everybody who leaves comments and suggestions and stuff, and the little likes and thumbs up, whatever. I do appreciate it. You know, all those little likes and comments or whatever help with the YouTube algorithm to suggest you for other people. So thank you for doing that. Otherwise, yeah. Thanks everybody, and we'll see you next time.